Today we are doing more verifying. Notice we don't have any instructions here, but at the top it does say that we are verifying these identities. So when we are verifying these identities, you need to pick one side to start with. So either you can start with the left side and prove that it equals the right side, or you can start with the right side and prove that it equals the left side. So the past 2 days, you were told, start with the left side, prove that it equals the right side. Today is going to be student choice. So you get to decide which side are you going to start on. So looking at number 1, do we want to start with the left side or the right side? Yeah, the only one that we have operations we can do is the left side. So we're going from left to right. So the only side we're going to work with is the left side. So we're going to recopy the left side. So secant squared of x. Inside the parentheses, we have 1 minus sine squared x. Bless you. What can I do first here? Yeah, inside the parentheses, we know that 1 minus sine squared is equal to cosine squared. So this is secant squared x times cosine squared of x. Yeah, then I could change everything in terms of sines and cosines. So instead of secant squared, I could change that to 1 over cosine squared. Don't forget the x times cosine squared of x over 1. What happens? Do I have to get a common denominator if I'm multiplying? No. Yeah, notice cosine squared in the numerator, cosine squared in the denominator. Those will cancel, so the answer is just 1. So again, we started with the left side. We proved that it equals the right side. Next one, problem number 2. We have to decide, do we want to start with the left side or the right side? Let's start with the left side. That's the only side that has operations to do for it. So recopy it. Negative sine of x over 1 plus cosine x minus sine x over 1 minus cosine x. And I'm just going to draw an arrow showing that I'm going from the left side and proving it equals the right side. Now, when you are proving these, there's several things that we can do. The first thing we could look for is a Pythagorean identity. So looking, I see 1s, but do you see it paired with a term that's squared? No, so Pythagorean identities won't help us right now. Next thing in our toolkit, we could convert everything to terms of sine and cosine, but that's already done for us. So step 3, yeah, I could look to see if anything will factor, but will anything factor? No, so the other thing we did yesterday was common denominator. So what would the common denominator be? 1 plus cosine x times 1 minus cosine x. Now those denominators are being multiplied, so make sure you group the binomials with parentheses. Now looking at the first fraction. The first fraction already had 1 plus cosine x, so what part of the denominator is it missing? 1 minus cosine x. So I already have a negative sign of x in the numerator, so it needs to be multiplied by 1 minus cosine of x. Now looking at the second fraction, it already has 1 minus cosine of x in the denominator, so what part of the denominator is it missing? Yeah, so that means the sine of x in the numerator needs to be multiplied by 1 plus cosine of x. Now before I can subtract these two fractions, I need to go ahead and distribute. So for the first numerator, distribute the negative sign of x. And for the second numerator, we'll have to be careful. It's actually negative sign of x that needs to be distributed here. Or you could leave the minus. That would be fine, but you'd have to remember that both of those would be subtracted. But let's go ahead and just distribute the negative with it. And when we do that, what's negative sign of x times 1? Negative sign of x. And negative sign of x times negative cosine of x would be positive sign of x cosine of x. And when I distribute the negative sign of x, what's negative sign of x times 1? Negative sign of x. And negative sign of x times cosine of x would be negative sign of x cosine of x. And the denominator, the common denominator, is 1 plus cosine x. That binomial is multiplied by 1 minus cosine of x. Simplify the numerator. What do you notice? Yeah, positive sine x cosine x, negative sine x cosine x. Those two terms will cancel. And the other two, combine them together, we get negative 2 sine of x over 1 plus cosine x, 1 minus cosine x. What should I do next? We don't have a Pythagorean identity. Yeah, go ahead and simplify the denominator. So we have negative 2 sine of x. And the denominator, when I multiply those, is a difference of squares. So 1 times 1 is 1. Cosine times negative cosine would be negative cosine squared of x. Now we have a Pythagorean identity because we have a 1 with a term that's squared. So instead of 1 minus cosine squared, what could I put? Sine squared of x. What happens next? Sine of x in the numerator will cancel with only 1 sine of x in the denominator. So that leaves me with negative 2 over sine of x, which is equal to negative 2 cosecant x. So now, did we prove that the left side equals the right side? Yes. One last problem, problem 3. Problem 3, when you are verifying these, you can pick. Do you want to start with the left side or the right side? Okay, let's start with the left side. So if I recopy the left side, it's sine to the 4th power x minus cosine to the 4th power x over sine squared of x. Now, have we dealt with anything to the 4th power? No, so we need to be able to get that power reduced somehow. So using everything we know for our toolkit, first would be a Pythagorean identity, but we really don't have a 1 here and we don't need to change anything. Second thing in our toolkit would be to convert everything to terms of sine and cosine, but that's already done. The third thing we talked about yesterday was factor. So will that numerator factor? Yes. What is that called? Difference of squares. What? That's a difference of squares. So factor your difference of squares in the numerator. So the square root of sine to the fourth would be sine squared of x plus cosine squared of x. And the other factor would be sine squared x minus cosine squared x over sine squared of x. What next? We do have another difference of squares, but before that, it equals 1. Sine squared plus cosine squared, that's my Pythagorean identity. So this is equal to 1. So that's going to be sine squared of x minus cosine squared of x over sine squared of x. Look at your answer. What do we have to have for our answer? A 1. Looking at my answer that I have right now, how can I get a 1? Yeah, sine squared of x divided by sine squared of x would be 1. So really, what I need to do is separate that fraction. So when I separate the fraction, sine squared of x needs to be divided by sine squared of x, and the cosine squared of x needs to be divided by sine squared of x, and subtraction in between the two fractions. And we already said that sine squared divided by sine squared is equal to 1. Bring down the minus, and we know that cosine squared divided by sine squared is cotangent squared of x. So now we have proven that the left side is equal to the right side. So a recap of all of the tools you can use when you are verifying these identities. What's one thing you should look for at the very beginning? Yeah, look for Pythagorean identities. See if you have a 1 with a term that is squared. What could you do next? Change all the terms to have only terms of sine and cosine. What's something else you could do? Factor. What else could you do? Common denominator. And what did we do at the very end of this problem here? Split up the fraction. So you can split one fraction into 2. So remember all of that as you're working on your assignment.